Hola, mi nombre es Cecilia Treviño y voy a presentarles el proyecto que realizaron mis alumnos de Mecánica de Fluidos. Durante este semestre estuvieron trabajando en el diseño de un sistema hidráulico para una casa habitación en la ciudad de Querétaro, en el cual tuvieron que calcular el suministro de agua donde ellos vivían para poder diseñar todo el sistema para su familia que estuvieran una semana sin suministro de agua. Esto debido a que en Querétaro el agua no es constante, hay mucha escasez y aparte por cuestión de pandemia, dado que todos los miembros de la familia están en la casa, los consumos han aumentado. Los alumnos tuvieron que diseñar por completo todos los instrumentos que iba a tener su sistema, tanto cisternas, tinacos, válvulas, bombas, etcétera, y después simular un programa en IS, que es un software de ingeniería, para que nosotros pudiéramos cambiar parámetros y de esa forma ver cómo se comportaba su sistema.
The following project is about designing a water storage system for the fluid mechanics course. Water shortages are part of the most common problematics in public services. The current situation added to the scarceness of this resource make this situation prone to be part of a daily basis in the future, therefore making a water storage system a necessity for every household.
The objective was to design a water storage system for a house in Querétaro, including the system capabilities, pump power, efficiency, and commercial prices for all the elements. To obtain data for the water storage system, it was simulated using EASE, along with an interface where the input variables can be changed by the user.
For the methodology, first, we estimated the volumetric flow rate and the dimensions of the house. Then we selected the important components such as pipes, water tanks, and valves. After that, we made an analysis calculating parameters such as head loss, head pump, and the friction factor within the pipes. Finally, we chose the system and the pump, and we simulated this system using EASE and MATLAB software.
System design. Our proposed design is composed of 2 water tanks, 1 water pump, 3/4 copper pipes, and several valves to direct the water flow.
For our component selection, we decided to use a 2,500 liter capacity tank, 5,000 liter cistern, and copper pipes based on their properties.
Pump selection. The pump selected is the Oakland BP1240 with 0.5 horsepower and a capacity to pump water over 40 meters. Our calculated head loss is about 8.2 meters, so this pump is able to fulfill the requirements.
This is our table of costs, where the 3 most expensive components were the 2 tanks and the total of copper pipes, giving us an approximate cost of 25,000 pesos.
And this is our EASE model. So with this model, the user is able to modify even the fluid properties or the pipe characteristics. In the fluid properties, he can determine or he can give the program the density, the viscosity, or the volumetric flow, or he can modify the pipe diameter, the pipe length, and the roughness of the material. The calculated values are the Reynolds number, the friction factor, and the head loss of the system.
So this is our team's presentation.
This is a design for a water storage system for a house here in Riquilla in Querétaro, where 5 adults live in. We have to study how was the consumption, and we get an average water consumption of 0.746 cubic meters per day, which equals to 746 liters per day. So for our design, we expect to have a water rooftop tank of 2,600 liters, while the cistern would be of 6,000 liters in order to work with the design.
A cement pump was chosen because it satisfies the need for a use of water for a whole family during a week, even if the water supply is stopped due to the conditions in Querétaro. These are the costs of the material necessary to assemble our system, where pipes made of copper, the tank and the pump present a higher cost.
Now here is our simulation. Here is an image of the interface where the input variables are the diameter, the density and the viscosity of the fluid, the material roughness of the pipes, the length and the height of the pipes. In the right side, we can see the results that are given from the simulation, like the head of the pump, head losses, Reynolds number, and friction coefficient.
In this drawing, you can see the general design of what we're proposing. Basically, water comes from the street and goes to the cistern, and then the water is pumped to the tank that is in the roof, passing through pipes. There you can see the volume of the tank and the volume of the cistern calculated, and also the different lengths for the pipes. In this slide, you can see the different components required for the system. You can see the couplings, the pipes, the check valve, the pump, the tank, and also the electrical switch.
As we can see in this slide, we have a table that shows the cost and the total cost of the system that we saw in the previous slide. Pump selection is a key part of the project. Here we have two graphs given by Pedroyo, and the model is CP600. We choose this model because we know our needs from results, and this model performs the highest efficiency.
Finally, as the system was simulated through MATLAB. In this simulation, a user-friendly pump calculator was created. This calculator allows its users to find the pump head and the pump power by giving the operation parameters such as flow rate, elevation, the pipe dimensions of diameter, length and roughness, the minor losses, and the pump efficiency.
As you could see, these three projects are very similar, and at the end, each team proposed a pump able to work correctly in its specified system. Simulations were created by each team, and these simulations allow to analyze the water pumping systems using different values, which can be something really useful. Thank you very much for your attention.